Sir, we can't hear you, sir.
Can you hear me now?
No, it's okay, sir. Can you explain that once again, sir? We couldn't hear you.
Yeah, yeah. Now can you hear me?
Yes, sir. Now it's clear, sir.
Yeah, yeah, fine. This one, regarding rod.
Yes, sir.
Okay, okay, that one. Yeah, some power got back. Okay, that one. Yeah. Okay, now, what is this? There's a rod AB. It's having a mass and length L, and center of the rod, let it be here. So there's a vertical wall. There's a horizontal ground. Oh, there's a ground, you're right. So I release it. The rod, what when in this way, what when the end A will move horizontally and the NB will move. I'm just asking what is the angular velocity of this rod? Straight away, I'm just trying to take an example, like what is the angular velocity of this given rod? No, is it, sir, why, what is the reason, where is the question of rotation, why you're asking? Yes, in fact, the rod is rotating. Rod is rotating, is it rotating about A, B or C? Yes, let's see that. Shall I say it's rotating about center of mass? How actually the motion of this rod takes place? I think first we should have a basic picture. So I think all these are very general. First, initially, the rod will be vertical like this. Initially, this will be the position of the rod. After some time, it will take this position. I think a big one. Yeah. Now you try. After some time, it will take position like this. Will agree? And after some time, it will be like this. Able to analyze at least the diagram. So this is the end A, this is end B, this is end A initially. So finally it will be like this: B1, A1, B2, A2. Look at this rod. Is it rotating? No, let's take the center of mass. Center of mass is here. After some time, center of mass is here. After some time, let the center of mass come somewhere here. Now, what is my basic question? What is the angular velocity of the rod for any given position? Let's say that when rod makes an angle theta, I want the angular velocity. I know, let me give the velocity of the ends A and B. So here, is it rotating about center of mass? The answer is no. So what we know velocity of the ends. So what we should do, I will go for, I know velocity. So I'll get a position vector, R bar. This should be what? R bar. And similarly, if there's a velocity vector, so I'll get a position where these 2 points intersect. That is what, like a instantaneous center. About this particular point, the rod is in fact rotating. I'll call this as RA. Let this be RB. And in fact, it's rotating with an angle of to omega. Now I'll also ask you further, what is the velocity of center of mass? In that case, what I should do, I should draw a perpendicular, this one. So because how the velocity of center of mass will be, so just drop a perpendicular this one. Then here what happen? It will have velocity. What is the speed of center? You can find out all this one. So what is RA? How to calculate RA? I think L sine theta, because length of the rod AB is L. RA equal to L sine theta. What about RB? L cos theta. If I give L and VA, then what happen with that? You can bring the omega. So what is VA equal to? RA into omega. L sine theta omega. So omega equal to VA by L sine theta, or VB is equal to RB into omega. You can use this formula. RB is what? L cos theta. Sir, you are showing different answer. Which is right? I think definitely theta is there. If theta equal to 45 degree, then VA equal to VB it will come. If theta is 30 or 60, definitely VA and VB will be different. So the rod is in fact about what point rotating, not about center of mass, about P. P will become instantaneous center. Rod is rotating about point P. This will be a little bit difficult. So what is the basic idea? V equal to omega cross R bar. From that is what I'm identifying that one. Now I'll ask you what is the velocity of center of mass. As you find out this distance RC, calculate the velocity of center of mass. Now again one more. We'll take one more example. Now I think you have enough of situations. This is not like only rod, you can go for any other object here. Now let me pick up a rod of, it can happen like this, no? There's a rod. Let me make a generalized discussion so that will be easy for you rather than doing one problem. Let me discuss. So at this end, at this instant, the end A, this is a point B, and this is C. Now I want the velocity of the end C. So what information I have is VA, and I'll give all other things. Length of the rod AC is equal to how much? Okay, we'll do one thing. D will write it. Length of the rod, AB, let it be equal to L. I'll give theta, then I'll give this height H. I think with that you can calculate how much AD. If you know theta and H, you can bring the AD. And if you know AD, length AD, then you can bring the BD. Overall, AB is how much? L is what I'm giving. H is given for us at this instant. Now I want the velocity of the point B. In what action the velocity of the point D will be? The velocity of the point D of the rod will be along the rod itself. But earlier, sir, previous problem you shown vertical. Now you are showing, because see, like after some time, see, this is now, I think now you must come to the general idea. For various instance, just make a guess how the rod will be. So this initially rod. No, let's say initially this will be the rod. You can see, no. Then after some time, what do we get? This will be the position. I'm just showing with a different color so that it will be easy for you to follow. Okay, agree this? This will be, now look at this, point B, what happened, will have velocity in that direction only? No. Look at this A. Look at this A. Now at this instant, the A must have velocity like this only, no? VA1 you call, now VA2. What about this? At the point D, initially it will have velocity like this, VD1. After some time, it will have velocity VD2. What about velocity of the end B? I don't know. I'm not very sure. I don't know. Like, sir, will it be along the rod? That has to be determined. No, where is the center of mass of the rod? Let it be here. Let me take this as center of mass. So rod rotates about center of mass. We don't know. So what is the method now? I know velocity of point D and A. I indicated that one. So with that, what happened? I'll go for predicting the instantaneous center. So for that, now the instant center should be. So I'll extend a. I'll extend like this. Now let me extend a line perpendicular to VD. So both are intersecting, you know. So this is the now about this point the rod is rotating. So call this is RA, this is RD. Now can I find out RA? Yes, we know, because we know the distance AD. H is given. From that I'll find out AD. I know theta, and this angle is 90 degrees, and this angle is 90 degrees. 90 minus theta, this will be theta. Fine. Rest all mathematics we know. We'll get the omega. If you know omega, then what you do? Come and bring the RB, that one. So what you should do now? How the velocity of point D will be. So from what you should do? What is the method? From B, what will happen? You should draw a line which should be perpendicular. So it's not horizontal. You can see it's not horizontal. Somewhere it is like this. I'll just make some small corrections. Because if I show horizontal, again, I'll be giving you some other concept. Yeah. No. So perpendicular to this, the velocity of point B will be. And it is rotating with omega. This is RA, this is RD. And I know from geometry, I can bring, this is theta, and I'll bring RB also. I'm able to tell the velocity of point B. Look at the velocity of point B. And what will happen to inner center? Is it a fixed? No. Again, this is something very important. For green color line, the instant center will be at one point. Sir, how do you can say this? Okay, how do I can say this? You can see like I'm taking the black color one, dotted line. Roughly what happened, I'm able to predict the instantaneous center. There's a one initially. For red color, I'll choose some yellow color one. Some rough diagram. So look at this instantaneous center P1, P2. When the rod is in green color position, it will rotate about P1. When it is at red color position, it will rotate about P2. I'll try to shift it down. We'll see. Okay, no. Yeah. See, it's all about students should put effort here. That's a major problem. You are not putting effort. Sir, effort means, sir, we are working. So effort means not like something. This one, here what you have to draw the diagrams. This will be like this. Huh? Sir, why not same angular velocity? Why same angular velocity? You can see that what happened, the center of mass got descended, no? The decrease in potential, gravitational potential will get converted into increase in rotational kinetic energy. Because of that, the ends of the rod will have different speed. Now the velocity of the rod here, I'm interested. So how the velocity perpendicular to that? It should be like this. Huh? VB1. So what about here in this case? So green color is position 1, red color is position 2. Agreed? I think I am giving everything similar. This is what the mechanism. Huh? Sir, is it only for rod? You are discussing only for rod. Why not any other body? Yes, it is applicable for any other body also. What is any other body? Show one example for any other body. Okay, let me take. Say, why rotational mechanics difficult? The reason is